Welcome back. So today we are going to continue working with functions, and we're just going to move into multiplying. So it asks us to use modeling or the distributive property. So I'm going to show you both methods, and I just want you, when you're doing practice on your own, to pick whichever method you're more comfortable with. So using either of these methods, we're going to solve the following function operations. So let's see, we're given three different functions. We've got a of x, b of x, and c of x. Okay, so the first one wants us to do b of x times c of x. So I'm going to use modeling for this example. So b of x is 2 terms times c of x, which is 1, 2, 3 terms. So I'm going to set up a 2 by 3 box. And yes, you could definitely do a 3 by 2. That would work as well. So b of x gives me 4x squared and a negative 3x. No, just a negative 3, excuse me. And c of x is negative x to the 5th, 7x squared, and a positive 2. So when I go to multiply b of x times c of x, we're just going to, well, multiply. So I've got 4x squared times negative x to the 5th. So I'm missing a coefficient, so I'm just going to go ahead and put a 1. So negative 1 times 4 gives me negative 4. And here comes our exponent rules. X to the 5th times x squared. 5 and 2 gives me 7 total x's, so x to the 7th. All right, I'm just going to keep moving sideways. So negative x to the 5th times negative 3, negative 1 times negative 3 gives us a positive 3x to the 5th. Okay, so now 4x squared times 7x squared, so 4 times 7 gives me 28. X squared times x squared gives us a total of 4 x's. And then 7 times negative 3, negative 21. And we keep our x squared. All right, last row. So 4x squared times a positive 2. 4 and 2 gives me 8x squared. And then 2 times negative 3, a negative 6. Now to simplify, we're really just going to combine like terms, and I'm going to write it in standard form. So again, we have b of x, would I put that in pink? Okay, so b of x times c of x equals, all right, so my first term, I've got 4x to the 7th, no more x's to the 7th. Sorry, negative 4x to the 7th. Positive 3x to the 5th. Okay, what's the next smallest? 28, so positive 28x to the 4th. Yes, these can get a little lengthy. Oh, I've got 2x squared. So negative 21x squared and a positive 8 gives me a total of negative 13x squared. And then I just have my little lonely negative 6, my constant at the end. So b of x times c of x equals this big, long, beautiful polynomial. Cool. All right. So that was using modeling. So let's go ahead and I'm just going to use the distributive property for the next one. So we have a of x times b of x. Okay. So a of x has 3 terms. B of x has 2 terms. So when I write this, I can choose which way I write it. So a of x times b of x. Now remember, I'm distributing. So either I'm going to distribute 3 terms to the 2 terms or 2 terms to the 3 terms. So if one of my functions has less terms, I actually want to write it first. So I'm actually going to start with b of x. So I'm going to start with my 4x squared minus 3. And then I'm going to multiply it by a of x. Okay, it's multiplication. We're just using commutative property. We're just reordering. So 2x cubed minus 3x plus 5. All right, so again, you could have, it will work both ways no matter how you do it. However, if I have less terms, I want to write that one first, because when I go to distribute, I'm going to be distributing the 4x and then I'll distribute the negative 3. So we're going to have a lot of terms here, so try and keep everything straight. So one whoop-de-doo at a time, a little whoop-de-doos. So 4x squared times 2x cubed. So 4 times 2 gives us 8. I'm going to leave myself plenty of room. That's why I'm dropping it down. And then x squared times x cubed. So 2 and 3 gives me 5 x's. All right, let's continue this. And again, if you're feeling comfortable, pause the video, try it on your own, come back and check your work. So 4 times negative 3, negative 12. And x squared times an x, remember, our invisible 1 is there. So 2 and 1 gives me 3 x's. 4x squared times positive 5, 4 times 5, positive 20. And I keep my x squared. All right, so I have distributed my 4x squared to all 3 terms. 1, 2, 3. Perfect. Okay, let's keep moving. So then we've got our negative 3. So negative 3 times 2x cubed. So negative 3 times 2, so negative 6x cubed. Negative 3 times negative 3x, positive 9x. And negative 3 times positive 5 leaves us with negative 15. Okay, let's see if we can simplify and combine any like terms. So I want to keep in standard form, so I'm looking for highest exponent first. So my largest degree is a fifth. So I have 8x to the fifth, followed by, and I don't want to like miss anything or leave anything out, so I kind of just cross them off as I go. That's what I was doing in the last example. All right, I don't see any fourth degree, so I'm going to go to my third degree. So negative 12x cubes and negative 6x cubes gives me negative 18x cubed. And now let's go to our x squares. So positive 20x squared. Oh, that's the only x squared. Okay, so I bring that down. Then we have a positive 9x. My only x, and then negative 15. So minus 15. So this is a of x times b of x. So these do tend to get a little lengthy, not super difficult, but there's a lot of room for little arithmetic errors. So just make sure slow and steady wins the race, okay? Make sure you're paying attention to those exponent rules. Don't make any simple little arithmetic errors. So just take your time and work through these. All right, so let's see. We got to have a real world example. So let's see. Yeah, this is kind of a stretch, but you know, it's like one of those 100 watermelon problems that we'll never really use. Okay, so we're going to go with this. What is the area of the high school field's base paths? Okay, let's read the problem. So the camp athletic director wants to arrange kickball games for high school students and middle school students. Because of the ages of the campers, the high school kickball field is larger than the middle school field. So the dimensions of the square base paths, all right, square, I'm thinking that's probably important, of the fields are shown in the diagrams below. Okay, so we're talking about just the base paths. So I've got the larger field, the high school field, and then the other one a little smaller is our middle school field. So we're just talking about the square base paths. So what's the area of the high school's path? All right, so again, keyword square. What do we know about squares? Length, width, both the same. So when we go to find the area of the high school path, length times width, so 2x minus 3 times 2x minus 3. Okay, I'm just going to use the distributive property, but if you prefer modeling, you can use that as well. So distributing this 2x times 2x, 2 times 2 is 4. Remember, you're invisible ones, so x times x, x squared because we have 2 x's. So 2x times negative 3, negative 6x, and now I'll distribute my negative 3. So negative 3 times 2x, another negative 6x, negative 3 times negative 3, positive 9. So I'm going to combine my like terms. So the area of my high school field, so this becomes negative 12x. And then I just bring down my positive 9 and my 4x squared. So this is the area of my high school field. So go ahead, I want you to pause the video and you do that middle school field on your own and come back when you're ready. So I set it up, x minus 8 by x minus 8. You could also write it x minus 8 squared. And why I bring this up is because this is a big problem. I have students that want to just distribute this squared to both terms, but you cannot do that. You can only do it if it's a monomial. This is not. I have binomial, 2 terms. So I am squaring something with 2 terms. So remember, 2 terms, x minus 8 times 2 terms. If you don't write it out like this, you will miss your middle terms. So it's very important that you expand the expression so that you multiply it correctly. All right, so x times x, again, put in my invisible ones, x squared, x times negative 8, negative 8x, negative 8 times x, negative 8x, negative 8 times negative 8, positive 64. So combine our like terms. So we have negative 16x, and just bring down your positive 64 and your x squared. So we've got our middle school area. We've got our high school area. I think there was one other thing they wanted us to do. Let's look back over. What is the difference in the area of the base paths? So what's the difference in the area? So if we're looking for the difference meaning subtraction. So if we take high school and subtract middle school, let's set it up. So our high school would be 4x squared minus 12x plus 9. And if we're subtracting middle school, remember, you are subtracting the whole middle school function. So remember, you must put it in parentheses or else you'll only subtract the first term. I'll keep saying this till I'm blue in the face. You've got to put it in parentheses or else you'll forget and you'll only subtract the first one. But we're subtracting all of middle school, which means we must distribute this negative 1 to each of the terms. So we have a negative x squared. Then we actually have now a positive 16x and a negative 64. Now that we've distributed that negative to all of our terms, now we can just combine our like terms. So high school minus middle school. The difference in the square paths is 4x squared minus x squared gives us 3x squared. Negative 12x and positive 16 gives us a positive 4x. And positive 9 and negative 64 gives us negative 55. So the difference in the base paths is 3x squared plus 4x minus 55. So again, operations when we're dealing with functions, which essentially is dealing with a lot of polynomials. Just make sure, nice and slow, keep track of those exponent rules. Make sure that you're distributing to all your terms. So only like your little whoop-de-doos, I don't know, if we got a better name for them, you tell me. But when we're doing that, do it one at a time so you don't accidentally miss something. All right, looks good. Have a great day.